Okay, welcome to a new week of Math 20. We last week had finished with everything about shape-shifting, and we could go on, but we can just spend lots of time with questions too. That's fine. Going back to the homework, if we look at our calendar, then rounding has been due a while ago. We just had a weekend. The reflections, if you can get them done soon, would be good. Over the weekend was great. I'll still count them as on time today. And then fraction format is due by the end of the day today. Percent format will be due at the end of the day Wednesday.
Wait, where do we find the reflections? It's just through email, right?
There's two ways to find it. Also, study session today after class or tomorrow at 2. So the reflections, you can either go to the playground icon with the kid playing on the playground, and under the explorations are the 2 reflections.
Okay.
You can also go to the achievements, and with the list of homework there, there's the link to each of the reflections here.
Okay.
I think so. Okay, so let's start with questions. Questions about anything we've done, from the lecture notes, from the textbook version of it, from the homework, of any kind of homework.
I don't have a specific question about the SI prefixes and the exponents and square roots, but can we go over those again just briefly?
Sure.
Thanks.
Can we go over them by doing some homework? Let me just make some random homework. Okay. So I'm just pulling up random homework problems because we can. When I'm moving from one metric unit to another, there's the shortcut. We make that list of letters, the acronym of the prefixes. So if you want to write them out as prefixes, you could. Kilo, hecta, deca, the plane unit. But this is too much work. No one ever actually does this. So what most people do instead is they just write the letters. And we just know, because we've done this before, that deca means 1/10 of a thing. Centa means 1/100th. Milla means 1/1000th. Deca would be 10 of them. Hecta would be 100 of them. And kilo would be 1,000 of them. It's also true, because we are living in the US, that we just never use these. We need them for a place value in scooting, but we're never going to start or land on those options. So once we have our list, the KHDUDCM, which I would write like in green, but think about like in blue, then I look and I say, where are we starting in this one? We're starting, whoops, let me make that in plane meters. So in this case, the plane unit we're using is meters, which would mean centa is centimeters, milli is millimeters, and kilo is kilometers. A different problem could have a different type of thing, like grams or liters here. But in this problem, we're dealing with meters. So we're starting with plane meters, and we're going to millimeters. So that's 1, 2, 3 scoots to the right. So if I actually wrote my number, because by now it's kind of crowded up here, I would do the same thing. It's 3 scoots to the right. I have a hidden decimal here that I'm not seeing. Remember that hidden decimal point after the 1's place value? So if I scoot 3 to the right, then I have to add 3 zeros. So I wind up with 5,420,000 millimeters. So that's the teacher lecturing, writing way too much version of this problem. Let's do it again with what you would actually write on your page, okay? So all you have to write is those letters are K, H, D, U, D, C, M. We are going from plane units to millimeters, 1, 2, 3. So here we will do the same, 1, 2, 3, and that gives us the 5, 4, 2, 0 that we had before, with the 3 other zeros after it. And I label my answer, and I'm done. Okay, questions on either the everything in my brain write it out lecture version or the I'm doing homework version of this?
So do you, sorry, so you want to see the scoots in homework or just the answer?
I would, yeah, the answer is the important part just to get it right, but I would write something so that you know what's happening. Otherwise, when you come back at the end of the term to study for the final, you're going to think, how did I get that?
Right.
It is certainly true that if we were all third graders in a different country that used metric system, then we would stop writing out my green and yellow things. We would just be so used to the scoots. But if it's new to you, I would write them out. If it doesn't help you right now, it will probably help you in 7 weeks. Okay, let's try another one. Okay, what's my first step, somebody?
Write out the KHDU.
Yeah, I write out my thing. Because as we just said, even if you don't need to this time, it will help you later. Oops, I forgot to quit my text thing. Go away. Okay. So where am I starting? Which letter?
At the U.
The U,
Oh, wait.
no.
At the C.
The C, the centa. Where am I going?
Kilograms.
The kilograms to the K. So that's a lot. 1, 2, 3, 4, 5 scoots to the left. So I will take my thing here and go 1, 2, 3, 4, 5 to the left. And I will wind up with 3.4402 kilograms. It's reminding you not to round your answer. This isn't terribly important. Why is it saying don't round your answer? Because that 0 we have measured. Right? It's not that hard to measure something to the nearest centigram. If you had a high quality scale, you could do that, right? That's a lot more weight than a milligram. That's 10 milligrams. And there's certainly scales that measure things to the nearest milligram. So we have real accuracy here that we measured. Just because we're writing it in kilograms doesn't mean we're losing any accuracy. So that's why the problem asked you not to round, to remind you that this is a meaningful thing. We know it's not 0.344021 because we actually counted the centigrams. Ready for the next one? Holler if I'm going too fast. Okay. So we've done meters, we've done grams. Here is one with liters. So again, I write my letters. I'm starting with plain liters. So here's my plain liters. And I'm going to milliliters. One last comment that you don't really care about. The rounding won't ever matter when we're moving to the right because we're going to get rid of decimal points. So either think of it like it's a trick question or think of it like it's a random question. That if you're moving to the right, then you're always having less decimal points. So the rounding isn't an issue. Questions on any of that? All good. Okay. Let's see. Is there one I can generate that does micro, just so we have micro? Here, micro. No, okay, I will give up. We are not getting lucky in getting micro. If we had micro, we would just have to scoot a little more. The last one at the end of measurement is the square root one. And this one is just, can you push this in your calculator correctly? There are a fun process if you were really bored called the Sieve of Eratosthenes that will find this. But all you want to do is plug it in your calculator, square root key 2304, and you get 48. I expect that these days you could just search in your search bar for that too. But
Do you always put the square root key in prior to the number?
usually on calculators, the square root key goes first.
Okay.
If you plug it in the other way, doesn't it just give you the root?
I don't know what it does. It depends on your calculator brand, probably. Should we take a quick tangent and talk about smartphone apps that do math for you?
Yes.
Yes, okay, so stopping homework for now. We've now reviewed these things at the bottom of the shapeshifting, the SI prefixes and the exponents. I'm going to open a new page, and if we go to the library, most of the library page, come on library, is the books. But if you scoot down, there's more stuff. So under the books, we have ebooks, which is just a link to the LCC Libraries math ebooks. Podcasts, one of the stars you can get checked off in your achievement list is reporting about a podcast, and some of them are fun. It doesn't have to be a current issue. If you want to jump back to This Week in Virology when the pandemic was just starting or something, then that could be interesting. And then under the podcast are apps. And you can get a star on your achievement list by exploring one of these and writing about it as described below. So if you have kids, Bedtime Math is an app that gives you a cute word problem with pictures and stuff at different difficulty levels based on how old your kids are. I don't think I would actually use it as instead of a bedtime story, but there you go if you just want random cute problems. Socratic is something that sort of helps you look things up better. It's like a different kind of web search. So if you want to know how to do a kilogram to centigram problem, you could just scan the problem with your phone using the phone camera, and it's not going to answer the problem for you, but it's going to recognize what's happening. Oh, you're trying to do metric unit conversions. So here's some videos and here's some websites and things like that. So it's a way to turn your phone camera to an input for a search engine. Photomath and Microsoft Math are quite different. They will actually attempt to solve your math problem for you. You'll just scan it with the camera and then it will write out steps for you. So if you were in a higher level math class, then you could use it to cheat on your homework. In Math 20, then it's not quite so useful because of just how our problems work. But Mathway is a third one like that, but you have to pay for it. So I'm not expecting anyone to actually care about Mathway, but people talk about it, so there it is. So if you are stuck on homework, or maybe like Rob's question at the beginning, I got something wrong, how do I know if I got it wrong? You could always see if these are able to double check your work for you. At the very bottom, just as long as we're here, there are 3 other Math 20 open educational resources, and they're not as nice as our webpage, but they do have some stuff there. So if you are wondering, can I get some more help about SI prefixes, then here's some links to other people trying to explain it in a free online textbook. So just more places to go if you need help with anything. Okay, questions about any of that? If you've never played around with Photomath or Microsoft Math, then it's worth playing around with. Even if you take it off your phone after a few minutes, it's not a bad thing. And if you have kids, it's probably worth looking at bedtime math, see if that's your cup of tea or not. And some of them are cute. Okay, what next?
Can we go back to the second homework of fraction format and look at problem number 8? I think I got really confused on that one.
Sure, the turn-in homework.
Yeah,
Turn-in homework, okay. Shape-shifting fraction number 8, the Leaning Tower of Pisa.
correct.
Okay, let me make it not quite so wide. There we go. Okay, so we want in the ratio distance not distance. We want the distance it leans. They're both distances. 2, and the fraction bar is like the word 2, and height. So we're just writing two numbers above it, one above the other. Oops. The only thing we could really do wrong is write the wrong one on top. So we just have to make sure when we do our writing it out that the amount it's leaning, which was which one? The 13 feet, is on top, and its total height is on the bottom. And that's all it wants. So the big lesson here is that the fraction bar is like the word 2. So leans to height, leans on top, height on bottom.
Okay, I think when I was calculating, I think I did it backwards.
You could also try reducing it, but that's not what it asks you to do. That's another way to make this bigger than it is.
So that's the answer then? You don't like calculate that or anything?
Yep, you don't do anything with it. It should be, if I go to my check-in bubbles, whoops, not scroll that way. And there it is. It's just saying which order are you putting it, or did you accidentally reduce it when you shouldn't have?
Oh, okay. So leans goes on top of height.
Right, because it's asking you what's the ratio of it leans. That's what it mentions first, so that's top.
Okay.
2 is like the fraction bar, and then height will be the denominator. Good question.
Will it typically be the case that what they ask you for first will go on top typically?
It's always true that what they ask you for, when it says something to something, the first one is on top. It might or might not be what they provide you first. In this case, they cited the numbers in the wrong order. But they could have given us the 13 feet first, right? There's no inherent order to these two numbers. But the ordering doesn't matter which one they told us first. It's the fact that by the word 2, leans to height, the leans comes first, then the fraction bar, then the height.
Okay, thank you.
So do we get to, can we redo these?
Yes, you are supposed to redo them.
Okay. And do you just want us to send you the first one and then keep on redoing without sending it to you?
No, I want all the codes.
Okay.
And the way the codes work, you have to click all your bubbles. So if you got 7 out of 10 right and you're redoing it to get 8 out of 10, then the 7 that you got right, you need to click those bubbles again. Otherwise, it's going to give me a funny code and say you got 3 right because you only entered 3.
Okay, because I sent you a code after I did it a second time, and then you were asked, then it said question mark. So I thought you didn't want me to resend you The
No,
second one
I
I
didn't
did.
see a code in that email.
Oh, okay.
I'm not sure you hit paste.
Okay.
Okay, other questions? So far, so good.
Yeah, I got one. Could you do or go over number 6 on the percentage format, the turn-in homework? I struggled with that one quite a bit.
Over percentage 6. That is a tricky one. Okay, so we're going to do the 4 replacements. Okay, remember this blue box I just pasted?
Yeah.
So we have 4 things to do. For whatever we're doing, we don't want to do it with a mixed number. Mixed numbers are always awkward. So our first step is to get rid of that. So we have 25 3/8%, and we're going to keep the percent sign around, but change our mixed number into an improper fraction. And you do that by multiplying the denominator and the whole number and then adding up here. So 8 25s, well, if I have 4 25s, that's $1. So 8 25s will be 200. So I'm getting 203/8. If you need review of why that works, try it with some smaller problems. So why, for example, would 3 1/4 be the same as 3 times 4 is 12 plus 1 is 13/4? Well, draw some pictures. So here I have my 3 pies, and then beyond that I have another quarter. So how many quarters do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So we're multiplying these two numbers because those are how many pieces are in the whole pie, and then we're adding back the tiny pieces that we had just floating around. Can I go back to the previous slide? Anyone confused about what I just said?
No, I think that's good.
Okay, so either just remember that or understand it. Understanding is it better, but at least if you remember how to do that, you're good. Okay, now step 2. I want to get rid of the percent sign. So now I'm focusing not on the amount I have. Oops, come back. There we go. But I want to say, instead of a percent sign, I want to write something else. And I have 4 options. I could write it as divided by 100, but that's not going to help me. So no, that's not what I want. I could write it as 2 decimal point scoots to the left, but I don't have any decimal point decimal points here to scoot with, so that's not going to help. I could write the whole thing over 100. If I tried that, then that looks kind of awkward. That's not really what I want. So my last option of times 1 over 100 in this case is the nice thing to do. Everyone okay with that step? Okay, so finally, I've taken a percent symbol, I've replaced it by something else that also means out of 100, and I can actually do my arithmetic. We haven't talked about fraction multiplication yet, we really will in a moment, but multiply across the top and bottom separately. So 203 times 1 is 203. 8 times 100 is, whoops, going to be 800. Can this reduce? No, so we are done. Questions about that? Okay, let's.
Oh, sorry. I thought I was unmuted. No, I just forgot the last step. I see what I did now, though. Thank you.
You're welcome. Okay, let's use that as a great segue to talk about our next topic. So now we're done with shape shifting. This means that in the topics, we're going to scroll down to Mad Science. It means when you're doing homework, and you're going to go to the Mad Science, right? We're now in our new big topic. So shapeshifting was everything that we did with one number only. In our second topic, we're dealing with expressions. An expression is when you have things stuck together with arithmetic. You can have addition and subtraction and multiplying and dividing and exponents, and all these things are sticking things together. It's like we're mixing them in the chemistry lab. What we don't have is any equal signs. We're not doing anything with equations yet, except that I'm lying to you. If we have an equation like y equals a bunch of stuff, then all we're doing is figuring out what that bunch of stuff is. So in this kind of equation, y equals a bunch of stuff, it really is just the expression. It's almost like the y equal is just an instruction saying simplify all of this stuff. So we're never going with this to worry about, can I do the same thing to both sides of the equation? We're not. We're just simplifying the stuff that's y equal to. So we can have an equation that we only care about one side, and we'll still treat that as mad science because we're just simplifying the expression on the complicated side of the equals. So read this intro a little more carefully, but that's what we're doing. The first thing we're doing with more than one number at a time is multiplying and dividing fractions. If you're in the free textbook, we're on page 65. If you're in the green textbook, we're in those sections. As often happens in this class, when we start talking about a new thing conceptually, I'm putting some pictures on the board. And for some of you, this will be helpful. For others, it's not. If it's not, ignore it. That's okay. But for the people that do have a brain that pictures help, let's draw some pictures. So, actually, before I forget, it used to be true that in Math 20, I was not allowed to give you answers to problems in the online notes. Part of Math 20 is you learning how to take notes, and so I wasn't allowed to give you complete notes that had answers in them. That was your reward for coming to class, was you could take notes and make them have answers. That's not true anymore. The math division has changed the rules. But if you notice, these problems here don't have a little button under them to click and see the answer. Some things do on this page, but not very many, because I just haven't had time personally to ignore my family and give you lots of answers. So I went through and did that for all of shape-shifting, because that's what I do for fun on my Christmas break. But from here on, there's just not as many answers as we go. So take good notes, and you can't rely on the website as much for showing you answers. I will try and put them in as I have time, but when you see them, they're missing, that's okay. We know they're missing. That's why you have random problems with answers. That's why you have textbook problems with answers. So I'm sorry, but that's life. Okay, anyway, back to here. We want to take a cake. I have a cake with 3 pieces. And I have shaded 1/3 of it. So this is my third. It's the one I care about. The way fractions work, the denominator tells us how many pieces there are total, right? 1, 2, 3. And the numerator tells us how many we care about. This one is my third, just one of them. Everyone with me so far? Okay, I'm gonna get rid of these for now. So we want to show multiplying 1/3 times 1/2. So if I was to do 1/3 times 1/2 as a picture, how would I draw that?
Another square with just half of it shaded.
Yeah, so if I cut my, that's a terrible cut. If I was to take a knife and cut my pie or my cake this way, then everything that was a piece gets cut in half. So you probably know the rule. If you didn't, then I just told it to you a few minutes ago. You multiply the top separately. 1 times 1 is 1. You multiply the bottom separately. 3 times 2 is 6. I'm sorry, my brain is off. I'm doing this wrong. What I want to do is write times 2, top and bottom here. I'm not wanting half of my piece. I'm wanting to cut it into 2 pieces. That was terrible. I messed up. Anyway, I'm thinking fraction multiplication when I'm just reducing and unreducing. Let me even write the word unreducing on top so I stop confusing myself. I'm sorry, I just confused all your brains. That was not good. Okay, so I am taking my piece, the 1/3 I care about, that was my third, and I am saying that now it's 2 pieces because I just cut it. So those pieces are 6ths because now there's 6 of them. 1, 2, 3, 4, 5, 6. But how many I have 2 of them. Oh, I'm going to write in the wrong color. Okay, let's do another one because I messed up. I'm sorry about that. Now I've confused everyone, even the people whose pictures normally would help. Okay, forgive my artwork. These are not shaded well. So here are cake pieces. 2 of the 3 pieces are mine. No, I should be multiplying. I'm sorry. My brain is just off. We're not doing reducing and unreducing, are we? We did that already. Okay, forget about the first example. I will just keep going. Now we want to multiply instead. That's a good contrast. I'll just pretend I wanted to do that. No, actually, I'm just going to skip this. Maybe next time. But since I've confused your brain, I'm not going to try and fix it. So multiplying fractions, you multiply across the top and bottom separately. I'll worry about the picture another day when we can start from scratch and not have fuzzy brains. So this definition is an algorithm, which is just a fancy word for recipe or process. You know algorithms for baking cakes or things in the kitchen. You know algorithms for the directions you use to get from your house to someplace on the maps, whatever. So it just means a process. But it's telling you multiply across the top, multiply across the bottom. It's a process. So there we go. Okay, let's do a problem the real way and not worry about the pictures that are messing us up. So 2/3, 7/5. Multiply across the top, 2 times 7 is 14. Multiply across the bottom, 3 times 5 is 15. And we're done.
Could you go
Sometimes we're
or
not done so much. The process doesn't get any harder, but we have that silly rule that we're not done until we're reducing, have finished reducing. So if we have 5/7 times 1/10, multiply across the top, 5 times 1 is 5. Multiply across the bottom, 7 times 10 is 70. But I'm not allowed to put a box around it yet. Instead, I have to say, oh, look, 5 goes into both of them. If you're not sure 70 divided by 5, you can use your calculator. That's okay. And now I can put a box around it.
wait, so why did you -5 from both things? Or what is that? I'm confused.
I'm dividing by 5, top and bottom.
Oh, you divide. Oh, okay. I didn't see those little things.
Because I have to reduce my answer to make it a good fraction answer.
Yeah.
So this was too much work. I have this big number of 70 on the page. Who wants that? So there's a better way to do things. Most of you probably know this already and are saying, but wait, right? So when we are multiplying fractions, canceling is doing the reducing early. So notice, by the way, this is not an algorithm. It's not defining a process. It's just saying that this means something or is called something. So if I was to take my, well, we can fit it on the same one. I could say I have my 5/7 and I'm multiplying it by 1/10. Instead of doing my divide by 5 top and bottom over there, let's do it over here. 5 divided by 5 is just 1. 10 divided by 5 is 2. And now when I multiply, 1 times 1 is 1. 7 times 2 is 14. And I have my answer right away. This is friendlier because on the bottom, there is no 70. I'm avoiding those big numbers. If you notice, the math is the same. I have to divide by 5 on top and bottom. I can't get around that. I can either do it as reducing or I can do it as canceling, but I have to divide by 5 top and bottom. Okay, this is an important page. Any questions about this whole page?
Wait, so how do you turn those numbers into 1 and 2?
I was doing 5 divided by 5, which is 1,
Okay.
and then 10 divided by 5, which is 2.
Okay, so are you always going to divide?
Yeah, because all I am doing is this division early.
Okay.
And reducing the fraction to make it a nice answer is always dividing top and bottom by the same thing.
Can you show another example of the canceling?
Yes, let's do lots more examples. Paste, paste, paste. There we go. Okay, so 3/5 and 1/10. In this case, I can't cancel. How is this different than that one? There's a 5 and a 10.
A 3 doesn't go into 10.
3 doesn't go into 10, right? Because what I am doing is reducing a top and a bottom by the same number, but doing it early, I need something on top and something on bottom. In this case, I do have things that are both divisible by 5, but they're both on the bottom. So
Can you
I'm not
flip it?
allowed to cancel. So I'm going to write that out because somebody is going to try and make that mistake on the homework. So cannot cancel
So
both.
the canceling is kind of just like, sorry, I'm brain farting right now. Bringing it down to its lowest form before you do all the multiplication, I guess.
Yes, it's reducing it, but early. So all I can do on this one is 3 times 1 is 3, 5 times 10 is 50, and we're done. Oops. There you go. Both, I should be more clear, both 5 and 10. Otherwise, you're going to look at this later and say, both what?
So if you're reducing early, it's always going to be top on the left and bottom on the right.
No, it doesn't have to be like that.
Ah,
So let's look at this. Okay, 6/11ths and 2/3. Okay, what can I cancel with the 6? The 2 or the 3?
The 3.
The 3. The 2 is also on the top. If they're both on the top, I can't cancel. I have to pick one thing on top and one thing on bottom. So 6 and 3, I'll cancel. What am I dividing by?
2.
No,
3.
3.
Sorry.
3 divided by 3 is 1. 6 divided by 3 is 2. Now when I multiply across, 2 times 2 is 4. 11 times 1 is 11. And I'm done.
And so is the point of doing this just to get the numbers lower so that they're easier numbers to work with from like the get-go?
Right, there's no 33 on the page.
Okay, yeah.
That's the only goal is to avoid the big numbers. And as always, I'm lying to you. If you're doing Math 60, and this was, okay, close your eyes if you don't care about his question. So x, I can divide both sides by 2x. Right? Sometimes I can get rid of entire variables and things like that. But if we're not in Math 60, if there's no letters around, then yeah, we're just avoiding the 33. But while you're doing this, the people who care are, if you take Math 60 in the future, this will be a big part of how to make things with letters nicer. Okay, let's do another. Holler if I'm going too fast. This one shows you that nobody in their normal mind has to be perfect. If I multiply this across right away, I could do that and get 60 over 120. 6 times 10 is 60, 15 times 8 is 120. And then I could reduce it, but that would be a lot of reducing. So let's do some canceling. And very few people do all the canceling on this one. But even if we cancel some, it'll still make a smaller number when we do finally multiply across top and bottom. So who wants to go first? What's one thing we can cancel?
You cancel on the 15 and 6, you can take 3 out.
The 15 and the what?
6.
6. So we can divide this by 3. 6 divided by 3 is 2. 15 divided by 3 is 5. Okay, next person. What's something else to cancel?
You could do the 10 and the 8 by 2.
I can do the 10 and the 8 by 2. 10 divided by 2 is 5. 8 divided by 2 is 4. If we wanted to, we could stop. And at this point, if we multiply across, we're getting something much friendlier already. We could keep going with the canceling. I can cancel out the 5s on this side. They are on the same fraction, but that's okay. One is on top, one is on bottom. I can make them 1s. I could also cancel out the 2 and the 4. 2 divided by 2 is 1, 4 divided by 2 is 2. And now I have nothing left, but 1 times 1 is 1, and 1 times 2 is 2. So the purpose of this example problem is that almost no one will cancel 4 times. The more natural thing for our brains to do is do a little bit of canceling, get something that is an unreduced version of 1/2, and then do a little bit of reducing to get to the 1/2. That's great.
I never knew you could cancel on the same side like that. Like I always thought you could do it across, but I didn't know that you could do it up and down.
Because remember, the only goal of canceling is reducing early, and we can reduce 1 fraction. We don't have to have 2 fractions to do reducing.
Okay, yeah, that makes sense. Yeah. My brain just never put that together before.
It's probably just that your old math teacher never gave you one that was like that.
Yeah.
So.
Yeah.
Okay. We can also do this with mixed numbers. As before, mixed numbers are always ugly. They're never a nice way to do things. So we always want to take our fractions, our mixed numbers, and make them something nicer. So 1 and 4/8, 1 times 8 plus 4 over the 8 gives us 12/8. Okay, what can we reduce here? Or what can we cancel here so we don't have to reduce as much?
You can do the 3 and the 12 and the 2 and the 8.
So the 3 and the 12, 3 divided by 3 is 1, 12 divided by 3 is 4. I can do the 8 and the what you said?
2.
The 8 and the 2. Oops, I thought I changed color. So 2 divided by 2 is 1. 8 divided by 2 is 4. I could multiply across now and get 4 over 4. Or I can say we can also reduce the 4s and just have 1. Let's do one that doesn't have quite so much reducing in it. Ready for the next slide? Okay, so let's take each of these separately. The 1 2/3, 1 times 3, and then we're going to add 2. So that's going to be 5/3. The 1 4/8, 1 times 8 plus 4. So what we really want to do is 5/3 times 12/8. Then I can say, well, divide by 3. Get 1 here and 4 here. I can divide top and bottom by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. 5 times 1 is 5. 1 times 2 is 2. I'm ending up with 5 halves. Questions on any of this? No? Okay, if you're tedious, don't listen to this, but it is true that this one is kind of a baloney thing. Why would I keep it 4/8 when I could just change that to 1/2? So maybe you are watching me and saying, for green, I would say that 1 and 4/8 is 1 and 1/2, and that's going to just be 3 halves, and I'll put a 3 halves here instead, and that's going to be much easier. So if you did that, that's great. But I'm trying to not do too many things at once as I'm lecturing. So okay, for fraction division, we do the same thing, but we flip the second fraction and multiply. And if you memorized that before but never understood it, go back to when we were doing the making piles of a fixed size and I was ripping up tickets. Maybe you had papers to rip up. See if it helps you understand why. But without repeating that lecture of why it works, we can just keep practicing it. So 1/2, instead of divided by 3/4, I'm going to flip it over and multiply by 4/3. Oh, look, I can cancel. Let me grab another one. So instead of dividing, I'll multiply, and then I flip the second one. So 2/3 becomes 3 halves. Oh, and there's more. 3 divided by 3 is 1. I can cancel out with a 6 and a 2. 2 divided by 2 is 1. 6 divided by 2 is 3. And I have some 3's here.
The only reason I did that is because my friend wanted to play this really annoying game that
That was really quiet. Can you speak louder?
I think it was her kid talking.
Ah, okay. If someone is confused, let me know. Okay, should we go back to the lecture? Do you want to look at this slide more? I should emphasize again that there's nothing wrong with not doing so much reducing. If I wanted to take 6/9 times 3 halves, and the only thing I reduced was here, and then I multiply across, and that's great. You don't have to reduce all those times. You get the same answer. The reducing is just to make it less work for having to, I'm saying, you don't have to do all the canceling. The canceling is just to make it less work so you don't have to reduce at the end. If the canceling seems confusing, do less canceling, more reducing. That's fine.
So if it's one number on top of itself, it's always going to be 1?
Yep,
Okay.
because that again is like I have a cake. I'm going to cut it into 6 pieces, and I'm going to shade all of them. So I have 6 shaded pieces. I have 6 total pieces. Whoops, that one's supposed to be there. I have 6 total pieces. So if I've shaded all, then it's 1, whether I've cut it into 6 pieces or 8 or 12 or any number. Did I explain that well enough?
Yes.
Okay. Okay, so what have we done so far? When we're multiplying fractions, we multiply across top and bottom separately. We cancel so we don't have to reduce as much at the end. To divide, we flip the second one to multiply. That's what we called an algorithm because it was a process. And videos on that. Okay, quick tangent. Your website bank of problems is all done now for shape-shifting. If you go to shape-shifting, for all the problems you have a video or just steps or just an answer. So anything in shape-shifting is done like that. Not every section has problems, but for the ones that do, they have, you pick the video or the steps or the answer. Once we get to Mad Science, it's often kind of empty. And that again is my free time. This is a new thing, the problem bank. So your video problems, if you don't see them here, that's just because they're hiding at the end of the section. We're finishing fraction, multiplication, and division, so we have some problems here. You can click on them and see the video of someone doing that problem for you. When I have time, I will move these to the problem bank and put in the step-by-step answers as something you can read and put in just the answer for people who just want that. But I haven't finished turning other people's videos into problem bank problems yet. So this isn't quite as nice because sometimes you just want to check your work and see if you did this. But for now, if you're looking for, wait a minute, I want more video examples and the problem bank is empty, don't be sad, it's in the lecture notes. Got it? Okay. Adding and subtracting fractions is more complicated. Now we're on page 181 in the free book, or these sections in the green book with zebra cover. You need common denominators when adding fractions. The denominator of a fraction, again, is like a word describing the type of thing. If we have sixths, then what do I have? I have a piece of cake that's a sixth of the cake. It's almost like saying inches or centimeters or oranges or something like that. You can think of the denominator like a label. So because they work like labels, then I can't add things that have different labels, just like I can't add inches and centimeters unless I turn one of them into the other, or I can't add apples and oranges and elephants. So just like we would have to turn one of these measurement units into the other to combine them, I have to take my denominators and find some common denominator before I can add them. So for people who like the pictures, if I have half a cake for Amy and a quarter of a cake for Beatrice, then how much are they eating together? I would have to take Amy's piece and say that it is 1/2, but I can't combine the 1/2 and the 1/4. I will need to do the unreducing that I accidentally demonstrated before and make this 2/4. And then if I have 2/4 and 1/4, I can finally add them up. When I'm finally adding them up, the quarters sticks around. We're again treating quarters now like a label, like apples or oranges. I have 2/4 here. 1, 2. And I have a 1/3 quarter here. So overall, I have 3/4.
So we wouldn't do that we wouldn't do that reducing thing here then.
Nope, reducing and canceling. Well, you might need to reduce this at the end, but canceling is only for multiplying.
Oh, okay. Okay.
Or
Okay,
dividing.
okay.
We change dividing into multiplying.
Okay. All right. Okay.
So
Thank you.
Good,
Yeah.
good point. I am glad that Chrissy said that. Once we're adding or subtracting, like we are now, then you can't do all that canceling we just practiced. Okay, let's keep going. Could we have changed in this problem things into halves? We could have. It would just be terribly awkward. I could have said that this is 1/2, and this, which is a quarter, is 1/2 of a half. And then I can try and add 1/2 plus 1/2 halves, and I get 1.5 halves. And there's nothing wrong with what I wrote, except that you all just hate it. Right? So this isn't how we do fraction math. Yes, we have 1.5 halves, but no one would ever talk like that. No one would ever do math like this. So this is just bad. So there's a right way to do this. We want to change things so that what's in common are the bigger number denominators, like the quarter, not the smaller denominator number, like the halves. If we have different denominators, we need to change them so they match what's bigger. And that was the moral of the story. Okay, I need to go back and open my new Jamboard because we're on slide 20. Okay, I'm not going to do this because our other pictures didn't work. So before we add, let's just talk about making the denominators match. There are 3 situations. Sometimes one denominator is a multiple of the other. And I'm going to grab all of this. So if we have a 1/12 and if we have a 1/6, and I'm drawing them far apart so no one tries to add them. We know we're eventually going to add them, but we're not worrying about that yet. Then 12 is a multiple of 6. I can do 6 times 2 and get to 12. Remember, we spent a lot of time talking about multiples early on. So in this case, I can take one fraction, the one with the smaller denominator, and only change it. And now I have 2 fractions that are all 12ths. If I wanted to add them now, I finally could. Make these bigger so Anna can see. Okay, again, I can't do any canceling here. I do have some reducing, but there's no way I could get it done early. We're adding. So this is kind of the nicest case. One fraction we don't have to change at all. We just use it as it is. we can take the other fraction and make it so that it matches that denominator. Everyone with me for this slide?
Finally.
So the second example is when there's nothing in common. Oops, actually, let me grab more than that. So here we have 1/14 and 1/15. They have no factors in common at all. So if my two denominators have no factors in common, then I can make them match. And I can do that by saying, we'll multiply this one by 15 and this one by 14. If I do something to the bottom of a fraction, to be fair, I have to do it to the top. So now they are both 14 times 15. I might not know what 14 times 15 is, but that's okay. I know they match. Because whatever 14 times 15 is, I mean, it's there both times. So what is 14 times 15? 210. Okay, questions about this slide? Everyone's quiet. The people who I can see are nodding their heads. They're okay. Okay, so 2 situations out of 3 so far. First situation, this number was perfect. We didn't have to change the 12. We can just make this one into a 12. Second situation, I look at them and I say there's nothing in common at all. I'm just going to multiply them by each other. Third situation, the other way it could be, is that 1/12 and 1/15, they have something in common. They have a 3 in common.
Okay, get out of here. Get out of here.
So I'm going to mute CA. Okay. So I could look at this and say, can I make one denominator into the other? No, I can't make a 12 into 15 or a 15 into 12. I could try the second thing. Can I multiply each denominator by the other denominator? And I could, but that's too much work. If I do that, watch what happens. So this is sort of the wrong way to do this problem. So now I have 15, and whatever 12 times 15 is, 180. So far, so good. Now I need to reduce. Well, let's do it a different color. And finally, we're done. So there was a lot of reducing we did at the end. This 180 was a big number. So now we get back to Chrissy's question that she didn't ask of, since we can't cancel because we're adding, is there something else we can do to avoid this big number? Because it's probably true that if we have a big number in the denominator, we're going to have to do a lot of reducing at the end. And we don't want big numbers and we don't want reducing if we can avoid it. So having these common factors, let's actually use that. So for now, I'm going to write on this slide, ignore the common factors. Means lots of work. Okay, ready to do it the better way? So the better way, unfortunately, is more complicated than canceling. It's not so bad. I'm going to look at my two numbers. And for each of them, I'm going to make a factor tree. So far in Math 20, whenever you've looked at factor trees, you went all the way down to primes. It was important to take this 4 and make it a 2 times 2. But we don't actually need that. We're using the tool of factor trees for a different purpose now. What I want to do is get all the things that are in common listed out. So 3 was what they had in common. And once I've done that, once everything that's in common is visible on my factor tree, it doesn't matter if I break up the 4 into 2 2s or not. I can if I want. It doesn't really matter. So that's step 1. Step 2 is whenever I have something that's in common on both trees, I get rid of the second copy. And then step 3 is the non-crossed out leaves, I will multiply. And for some people, it helps them to circle the ones that are distinct. I find that clutters up my page a little, whatever makes you happy. So what is not crossed out? This 3 is not crossed out. This 4 is not crossed out. That 5 is not crossed out. And when I multiply all of those together, I get 60.
Why is that first 3 not crossed out?
Because I only cross out the second ones. Let me write out my steps.
Why do you only cross out the second one?
Because that's just how it works. So here's my process. So 1, factor trees. Show common factors. 2, cross out second of pairs in common and 3 multiply not crossed out. I should put that in the typed lecture notes after today.
So we're not adding anymore, we're multiplying now. Or is that just for the denominator while we do this process?
Just for this process, we're multiplying. We still have to add the fractions once we get common denominators for them, but we don't have common denominators yet.
Are we doing anything to the top ones, or are they still just ones?
They're still just ones for now.
Because we
Yes,
just are
you know.
are pulling out. We're just pulling out. We're just pulling out. Yeah, we're just pulling out numbers. Okay, I got it. I think. I don't know.
No, this 60 is our goal.
Right.
And 180 was too big.
Right.
60 will work.
Right. And so we're just
So what-
pulling out the factors.
And what we're saying is
that are
12
in
times
common.
something is 60.
Okay.
So what's it going to be?
5.
5. And if I do a times 5 on the bottom, I have to do it on top. And similarly, 15 times something is 60. I'd be saying it, but muted. So 4. And if I do 4 on the bottom, to be fair, I have to do it on the top. And then finally, I can say 560 plus 460 is 960. And I have to do a little bit of reducing, but not as much. So if you were not good at mental division, how did we know that this is a 5? Because it's the thing that's not on this tree. How did we know that this is a 4? Because it's the thing that's not on its own tree. So the missing ones from one side go in this box. And the 5 was missing from this tree, so it goes there. It's up to you which slide you like. It's sort of like riding a bike. And I'll do more of these, but sometimes people just never get fast at this process. So if that's true, then you can always multiply each number by the other and reduce a bunch. There's nothing wrong with this. Sometimes, again, you have to do it because they have nothing in common. But when they have something in common, if you can get used to this process, it's faster. So let's do more of them. Yeah, there we go. That. Okay, so without all the talking as much, let's see if this works now. So we have 1/30th and we have 1/42. What's the number in common?
Is it 6?
6. 6 is the biggest thing they have in common. Everyone see how Justin got that? If you weren't sure, make a whole factor tree and you'd get a 2 and a 3 and so on. So this one is 6 times 5. This one is 6 times 7. There's 2 6s. So we're going to get rid of one of them. And then our goal for the denominator will be what's left over, the 6 that's not crossed out, the 5 that's not crossed out, the 7 that's not crossed out. So 210. This 7 means that there's a times 7 top and bottom here. This 5 means that there's a times 5 top and bottom here. So finally, we can add them. And unsurprisingly, we have a little bit of reducing to do. That's even, isn't it? I can divide by 6 because 2 and 3 are both going to work. Okay, questions on any of that?
How did you get the 7 plus 5?
By just not writing as much. So this was the 7 2/10ths, 7 210ths plus 5 210ths was. So I could do 7 2/10ths. Make that look like a 7.
If you memorize your multiplication tables, it makes this a lot easier.
That is true. Does that help, Crystal?
Thank you.
You're welcome.
Can we do another one of those?
Sure. Before I do one more of these, I want to use this one in other ways. So let's do this problem, but for the other methods for people who hate this method, because I don't want to focus too much on this method. It is a good method. If you practice it, it's the fastest method. But if it's just not your cup of tea, then there's other ways to do this. So we could do the brute force method. And say that 1/30th plus 1/42nd plus 140. I'm just going to multiply each denominator by the other. That always works. I don't know what 40 times 32 is, but whatever it is, it's there both times now. Everyone see what's happening? If I do something to the bottom, to be fair, I have to do it to the top. And voila, I have 42 somethings plus 30 somethings. What is 30 times 42? 1,260. My calculator did that for me. So I wind up with 72 over 1,260. This method starts much faster. I don't have to do any of that baloney with factor trees. But now I am kind of in trouble. That's a lot of reducing to do. I can see that they add up to something that's a multiple of 3 and they're both even, so 6 is going to work. And again, add up the digits, I get something divisible by 3, and they're both even, so 6 is going to work. So some people think this slide is terribly confusing. They would much rather do it this way. Yes, we had to do more reducing, but it's worth it to not have to play with the factor trees.
Do you have to do the reducing twice? Or if you already know that it would be 12, can you not put 12 up there instead of doing 6
If you knew a 12 could work in the first step, you could do a 12 in the first step. If you didn't see the 6, I could do divided by 2, divided by 2, divided by 3, divided by 3, right? You can whittle away at it with very small steps of reducing if that's what's best for you. So if reducing isn't too bad for you, and factor trees are, then skip the factor trees. Just do this method. There's a third method. So I'm trying to find something that's bigger than 30 and 42 that will work. So I can just say, let's list out my multiples of 30. 30 times 1, 30 times 2, 30 times 3, 30 times 4, 30 times 5, 30 times 6, 30 times 7, and so on. And for 42, 42 times 1, 42 times 2, 42 times 3, 42 times 4, 42 times 5. And look, here is something on both lists. So I can do that. I can take the 1/30th and the 1/42nd and make them, whoops, into something over 210 plus something over 210. What am I going to multiply by to get from 30 to 210? If you couldn't see it, you can always label them. Times 1, times 2, times 3, times. So this was a times 7, top and bottom. This was a times 5, top and bottom. So this method is not terribly popular. It tends to involve writing lots of big numbers on the page, which most people want to avoid. But it's also sort of the most straightforward. If I was trying to show something to a second or third grader that had a lot of free time, this is an easy one to explain compared to the other two. So some people like this. The calculator can do all the multiplying for you. It's not like you have to know your 42 times tables. So 3 different ways to get common denominators. Let's go over them again. The first way is look for what they have in common and sort of fix it. In the easiest case, I can just take a small number and fix it to be like the big number. In the complicated case, I do this stuff with factor trees. The second method is just multiply each denominator by the other one. That will always work. It might make something huge, but that's okay. Reducing isn't too bad. And when there's nothing in common, I have to do it that way. There's no shortcut I can use. Lastly, you can always just make lists. for each denominator's times tables and pick the smallest thing on both lists. Okay, that was a whole lot. Any questions about any of that?
And all this is just to find the least common denominator, correct?
Correct. This is different ways to do it because there's almost 30 of you and people's brains work different. You do not need to learn all of this. Pick the method you like best and practice with that.
See, I never knew there was the other ways. I was always taught the third way.
Unfortunately, if math teachers in elementary or middle school were only taught one way, then they just teach it only one way. And if you happen to have the brain that works their way, then you think you're good at math. And if you don't and like some other method, then you think you're not good at math. But the more confusing thing is for me to show you all these ways, and then it's your problem to figure out which one works for you. But hopefully that reaches everybody. Okay, I'm going to be done with like stuff that you should pay attention to, except let's just sort of look what's happening in the next bit because it's almost time to be done. So we can do this more. Subtracting is just the same. We'll do lots of example problems. You can too. If there are 3 fractions, then we'll have to find a denominator that's in common for all of them, which is a little more work, but not too bad. If you want some video help, don't look in the problem bank, it's here. At least for now. And then later on, we'll talk about subtraction, and that's almost done. We'll have a little bit more with order of operations and PEMDAS, but we've done all the hard part of the fraction section. If you want to, before Wednesday, you can do some homework. You could go to the homework page, you could look at the random problems, and say, oh, I'm finally ready to click on Mad Science and fractions and try a few of these problems. If you want to just wait and have me do a bunch more example problems on Wednesday, that's fine too. I don't know what your week is like. I'm not sure how much today's lecture was sufficient. We're not ready to turn in anything yet because we haven't finished fractions for Mad Science. But you could do a little more practice if you want. Another excellent thing to do would be, to go to, come on, there we go, to go to the textbook and say, let's look at page 165. In fact, why don't we just do that? So read about what they are doing here on the textbook. Let's shrink you away. So, okay, this makes sense. I like their example problems. If only my silly LCC teacher explained things this clearly. I'm going to click on their videos, whatever. So look at the book also. That's a good thing to do after we're done, is to go to where it tells you for fraction multiplying and for fraction addition and see how someone else explains it. If you have time, we'll be doing a study session in a bit, so maybe I'll see some of you there and you can get a head start on homework. You could certainly work on the Mad Science fraction turn-in problems that are appropriate for this. Get them done right away as a group. But yeah. Okay, fractions can be tricky for people. People arrive at Math 20 with lots of baggage about fractions. So if most of Wednesday is repeating things today with different words, that's fine. We'll have other example problems and other ways to explain it. Anything else before we're done? I'm going to stop the screen share. I'm going to stop the record. You can say goodbye to each other and not be